How you doing? Hey, we're studying radical expressions today, and there's going to be a several-part series in this. And today I'm going to show you how to simplify some radical values. And first thing I'm going to start with is the square root of 48. Square root of 48 is approximately, it's real close to 7 because the square root of 49 would be 7. But the best we can do with this is approximate that with a calculator. So what we want to try to do is simplify this by seeing any perfect squares that would go into 48. Now there's a couple perfect squares that go into 48. 4 would be a number that goes into 48, as would 16. Now you should use the largest perfect square that would go into that. So I'm going to rewrite the square root of 48 as the square root of 16 times the square root of 3. The square root of 16 I use because it's a perfect square. And what is the square root of 16? Well, it's 4. So the square root of 48 is equivalent to 4 times the square root of 3. Now sometimes it doesn't look like that's simplified at all, but that would be in its simplest form because no other perfect square goes into 3. Okay? Now, if it's a cube root, like I have a cube root of 27 or 72 up here, I'm not thinking squares anymore. I'm thinking perfect cubes. And so now I have to know what my cubes are. And I'm thinking of what numbers multiply together, what factors of 72 would happen to be cubes. Well, I know 8 times 9 is 72, and 8 is a perfect cube. So I'm going to use 8. So I'm going to rewrite this as the cube root of 8 times the cube root of 9. Now, the cube root of 8 is 2. So this works out to be 2 times the cube root of 9. Now, be careful that you don't say, oh, well, 9's a perfect square. It's 3 times 3. Well, that's nice, but we need perfect cubes that go into 9. And there are no other perfect cubes that will go into 9. So 2 times the cube root of 9 would be the cube root of 72 simplified. Likewise, if I have a fourth root, I need to think about what perfect fourth roots would go into the number in here. Like this one's 128. So if you don't know your fourths real well, then I suggest that you make a little chart up and use that to help you. But I know 16 is a perfect fourth root, and I also know that 16 times 8 is 128. So I'm going to rewrite this as the fourth root of 16 times the fourth root of 8. And the fourth root of 16 is 2. So this simplifies to 2 times the fourth root of 8. And we'd leave all of these with a radical sign still in their expression, but they would be simplified. Now, if it happens to have variables with it, like this is the square root of x squared, y to the 6th, what you do is you take the power and you divide it by the root. In other words, that has a power of 2, and the square root would imply that there is a 2 there. And so you would take that 2 divided by that 2, and you'd get 1. So this becomes x to the 1. If you take 6 divided by 2, you would get y to the 3. And so this simplifies the square root of x squared y cubed would be the same as x times y to the 3rd. If it's a cube, okay, if it's a cube, then you divide this number, this x to the 4, you divide that power by 3. And 4 over 3 is 1 1/3. Now, if there is a remainder, like 1/3, that you still are going to have a radical sign in your expression. These didn't because these numbers 2 and 6 went into 2, or 2 goes into those evenly. In this situation, 3 does not go into 4 evenly, okay? And so we're still going to have a radical in our answer. However, if you look here, I have y to the 6th, and y to the 3 does go into 6 2 times, and so your answer for this one is going to look like this. It's going to be x to the 1, y to the 2, and the cube root of x, and I'm going to show a little 1 right there. This would be your overall answer in that situation. Now you don't have to show x to the first power. I was just showing that that is the remainder of 4 over 3. So 4 over 3 would be 1. That would be this x to the 1. And 1/3 would be this expression. So that's what you do when it doesn't work out to be, well, a perfect cube or fourth or whatever your radical power would happen to be. Now, the last thing I'm going to show you on this video is how to add and subtract radical numbers. What you do is you see these as like terms, and I have an example over here. Over here I have 3 times the square root of 2 plus 4 times the square root of 2. Now, I'll move this a little bit. Because these are both square roots of 2, I can treat them as like terms. Like if I have 3 of something plus 4 of something, I would have 7 of that something. And in this situation, my somethings are square roots of 2. And so my answer for this would be 7 square roots of 2. So you add them just like they were any other like variable. However, the difficulty comes in when you have an expression like this, like square root of 20 plus square root of 125 minus square root of 45. None of those are like radicals. However, what I'm going to do with those is I'm going to simplify them like I did up top here and see if I can't get like radicals that I can add and subtract. I'm asking myself, what perfect square would be a factor of 20? And I know 4 is perfect square, and 4 times 5 is 20, so I would think of this as the square root of 4 times the square root of 5. I did the same thing with 125, and 125 is 25 times 5, so I can write the square root of 25 times square root of 5. And 45 is 9 times 5, so I can write that as square root of 9 times square root of 5. Now notice that I chose 4, 25, and 9 because they are perfect squares. And so when I take the square root of 4, I would get 2 square root of 5. The square root of 25 would be 5, square root of 5. And the square root of 9 would be 3. So now I have 2 square root of 5 plus 5 more square roots of 5, so that would give you 7, minus 3 square roots of 5. 7 minus 3 would be 4 square roots of 5. So 4 square root of 5 would be my answer for that addition and subtraction problem, that sum. Well, I hope this makes sense to you, and I would imagine that if you're struggling with something like this, that this video just might help you out. So, hey, thanks for stopping in, and we'll talk to you later.